Hi guys. Well, we've had an interesting week. We've missed Monday for Martin Luther King Day, and then we're missing Wednesday, or at least the day classes, because of bad weather. So this is going to put you in a little bit more of a bind that we can take care of. It'll work. It'll work itself out. It just is putting a little bit more emphasis on you doing some outside of class work. Okay, so in addition to the many hours of studying, now you're going to just have to throw in a few more. Okay, so what we're going to look at today on this video, we're going to be doing tissues. We've covered epithelial tissue in class and a little bit of the beginning of connective tissue. A future video, I'll go back and redo the epithelial tissue. I just want to make sure you get the information that you need for this portion. So because we've missed class, it's even more imperative that you review the PowerPoint presentation. I recommend printing out the notes, okay, and fill those out. And then thirdly, watch these videos, okay? So definitely go through that information. Any of the information that you are somewhat uncertain of, then you want to open up the book and look at that. You've got your Connect sources. Definitely look at that as well. Okay, so you want to stay on the anatomy components of this, not so much the physiology. But let's look at this. Okay, so let's start this off first by let me get my pen working here first. Let me just do a color. There we go. So let's look at this first, and who can recall what the definition of connective tissue is? Okay, if you can recall that, great. So connective tissue are cells in a matrix of fibers and ground substance. That's a U. Okay, so that's the definition of this. So let's look at those three different components separately. And we have cells, we have fibers, and then we have the ground substance. That's an N. So this is ground substance, fibers, and cells. And let's make kind of columns so we can separate these out. Not straight lines by any imagination. And let's look at this. So what we're looking at on cells, let's look at some of the basic tissue types. All connective tissue originates from the same type of cell. It's a stem cell, and that's called mesenchyme. It's a mesenchyme cell. Since it's under the cell column, I'm not going to necessarily put it in the word cell, but mesenchyme is a stem cell, and stem cells can differentiate or specialize into other types of tissues. Okay, so all your connective tissue, all the cells in there originate from mesenchyme. And some of those different types, you're going to have one which is a fibroblast. Now, a lot of this should be refreshing your memory for what we did. Fibroblasts make fibers, okay? And we'll cover fibers in a second. Other ones, we're going to have adipocytes. That's a C-Y-T-E. Adipocytes are fat cells. Okay, adipose tissue is made up of adipocytes, and these cells are kind of neat looking. Not the most interesting cell to me, but they're kind of neat looking, which is they're just pretty big cells. They don't look like there's anything in them. It's just kind of a blank white spot underneath the slide. And if you get the section correctly, you can see a small nucleus being pushed off to the side and maybe you can see a little bit of cytoplasm next to that, okay? So that means all the rest of this stuff, all the space in here, okay, is going to be a fat droplet. It's triglycerides, but it's a fat droplet, okay? Now you have a set, essentially a basic set number of cells, and gaining or losing weight, you're not gaining or losing fat cells, you are actually making those cells larger or smaller. So that's one of the key things that you are looking at. So that would be adipocytes. You can have immune cells. So those are lymphocytes. You can have leukocytes. You can have macrophages. You can have mast cells. So these are just different types of cells. Now, is it all inclusive? No. There's a whole bunch of different types of cells. You can have bone cells and you can have cartilage cells. And when we get into those areas, we'll talk about those a little bit more. So that's what we're looking at on your cell types. So let's look at fibers. Let me get this back to yellow. So fibers, there's going to be 3 flavors of fibers, okay? Can anyone recall what those are? Okay, so your first one is collagen. And collagen, I gotta have an N on that. A collagen fiber, or collagen fibers are cable-like fibers that are very tough. They're very, very strong. They are flexible, but they don't stretch, okay? So if you were to compare a collagen fiber, the same size of collagen as you would have a piece of steel, collagen fibers would end up being stronger than the same size in a steel fiber, okay? 25% of your body protein is made up of collagen fibers, and you will find these in tissues like ligaments and tendons, okay? All the fibers are lined up really nice and neat, okay? There's a little wavy to them, but that's going to be what collagen fibers are. Down the road, I'll probably put up a short little video here on the histology of connective tissue. I'll show you some pictures of the different types of tissues on that one. The second type of fiber is going to be reticular. Now, reticular fibers, if you recall, is made of collagen. Okay, so it's made of the same stuff that makes this. A little slight differences, but it's made of the same stuff, except it's thinner. So it's still tough. It's still very flexible on this, but just not as much as your other collagen fibers. And these reticular fibers form some solid organs, so it forms a framework or a structure for some of these organs. You're looking at your spleen, your lymph nodes, parts of your liver is made up of the reticular fiber. That's giving you the framework for those organs. The third one is going to be elastic. Okay, everybody's favorite fabric around Thanksgiving. All right, and elastic fibers are made of a protein called elastin. Are made up of elastin. Okay, now elastic fibers are stretchy and then they recoil. Okay, which is why your sweatpants are so cherished at Thanksgiving. It allows your body to stretch and then it comes right back down. So it makes them very comfortable on this one. You're going to find elastic fibers in, let's say, your arteries. You're going to find them in your lungs. You can find them in your skin, okay? Because skin, it has to move in different directions, okay? And then it recoils back down, okay? Why would you find elastic fibers in your arteries? Okay, think about it. Elastic fibers allows for stretching and recoiling. So if we have an artery, and this is just a tube, okay? So if we have an artery here, every time your heart contracts, it pushes blood out and it pushes it out into the arteries, okay? So when your blood is being pumped into the arteries, you have an increased amount of pressure. And what happens is your arteries stretch out. Okay? So when you're feeling your pulse and you can feel that beat, you're actually feeling your arteries getting bigger like this. Okay? Now, what are the elastic fibers doing? Well, if you stretch the artery during heart contraction, because blood is being forced through it at a pressure, the elastic fibers allow it to come back down. So you stretch and then it comes back down. Okay? So that's going to be elastic fibers. And then your third component of connective tissue is going to be the ground substance. And your primary component of ground substance is going to be water. Okay? And some tissues will have more waters than other. But it's not just water by itself. You're going to have solutes, dissolved substances in the water. You can have amino acids in there. You can have other oxygens dissolved in there. You can have a number of different things dissolved in the water. A couple other components. You're going to have something that's called glucosaminoglycans. Not going to spell that out, but it often goes by the GA. That's a G. Okay, GAG, glucosaminoglycans. Another one is going to be proteoglycans. Proteoglycans is just basically a glucosaminoglycan with a protein molecule attached to it. Okay, both of these are hydrophilic. So let me proteoglycan. Proteoglycan, Glycan. I think that's how you spell it. Proteoglycan. And both of these are going to be hydrophilic. Which means it attracts water. Okay. Some of the glucosaminoglycans, you can buy some of these over the counter at your nutritional store, which would be chondroitin sulfate. You might have seen commercials on chondroitin sulfate. A lot of people take those for like arthritis. You can have hyaluronic acid. And those substances, they're hydrophilic. They attract water. Some substances attract more water than others. Okay? And the differences would be blood is a very liquid. Bone is not so. Okay? So depending on how much water you have determines the consistency of this. So you can have a solid connective tissue, very little bit of ground substance, meaning very little water. You can have a semi-solid structure, such as a tendon or a ligament, or you can have a very liquidy one, which would be blood or lymph type. Now, if you recall in class, what makes this a little bit easier to understand, this is just a recipe. Depending on what cells you put in it, what fibers you put in it, and how much water you put in it, you can make different types of connective tissue. So the example I gave was the chicken noodle soup. Okay, so in chicken noodle soup, the cells would be, say, pieces of chicken, or they would be pieces of carrot. Don't want to get too vegetarian on this. So those would be the cells. The noodles in chicken noodle soup would be the fibers. And depending on the type of fiber you can have, let's say, lasagna noodles. Those would be the collagen fibers. Very big, very strong, very tough. You could have angel hair pasta. Okay. You could have, fusilli, the spiral kind of pasta, which would be elastic. Okay. So you can change the consistency of the fibers. And then some people like a lot of broth in their chicken noodle soup. So the ground substance would be the liquid that the cells and fibers reside in. Okay, so if you have a lot of water, it would be more of a liquid base, or if you have less water, it would be less so. Now, you just don't put water in chicken noodle soup. you put the chicken broth and you put, salts, and then you put other flavorings in that. Okay, so those are the various solutes as well. Okay, so depending on the recipe that you have, you may have a chicken noodle soup recipe, your mom might have one, your grandma might have one, Edith next door might have a completely different one. So they're all connective tissue. We've just changed the recipe up a little bit. So let me do one more thing. Let me scroll down on this. Let me do one more thing. Let's just go through a little bit of the functions. Functions of connective tissue, briefly. We are looking at a protection. Okay, protection. If you look at bone is a connective tissue. So if you look at bone, your ribs are protecting organs underneath. So pelvic bones are protecting the pelvic organs. You can have supporting or binding. Support or bind. Okay. Your skeletal system allow for attachment of muscles, so it's supporting that. Cartilage keeps your trachea open. You can bind structures together, ligaments or tendons. Ligaments attach bone to bone. Tendons attach muscle to bone. So that would be this one. You can have storage. Storage, you could store energy. Energy reserves would be stored in adipocytes, the fat cells. Okay, that's what you use for energy. You can have bones, and it's a storage or it's a reserve for calcium and phosphate. Okay, you can transport stuff. Transport, that would be like your blood. You can transport oxygen. Waste products, carbon dioxide, you can transport glucose, you can transport amino acids. So transporting is another function of it. And then you're going to have your immune system. Okay, so you can have the lymphocytes, immune cells of your lymph system. You can have leukocytes, white blood cells, macrophages, you can have mast cells. Okay, so those are different types of cells that you can have for this one. So that's it for this video. I'll make another one on the next part where we're going to talk different types of connective tissue. So that's it for today. Talk to you in a minute.